Lecture 5 in the second section of the course on organic contaminants in the subsurface. In Section 2, we're dealing with monitored natural attenuation, and we're emphasizing the processes that could bring about attenuation. We've discussed advection and dispersion. We're now going to move on to retardation. Again, retardation is where the chemical interacts with the aquifer solids and spends some time attached to the aquifer solids. It can move back into the contaminant plume, but spending some time on the aquifer solids causes the overall contaminant to move more slowly. So for many people, it's a good process. It delays the arrival of contaminant plumes. Hydrogeologists can deal with the amount of retardation, the amount of delay, through the retardation equation. Again, it's designed for a system where the contaminants partition between the water and the solids. And in Section 1 of the course, you discuss partitioning and the controls of partitioning. You discussed the KD concept, which describes that partitioning between the solids and the aquifer water. This is the equation that we use to describe it. It's taken from hydrogeology, where the interaction is absorption among cations, but it also applies with some modifications to organic contaminants. The retardation is the difference between the groundwater velocity and the actual velocity of the contaminant. For a general estimate of retardation in sand, you can use values of 1 plus 7 times the factor KD. So clearly we would like to determine KD. Well, we can relate KD to the amount of organic matter in the aquifer solid, as well as the octanol water partitioning coefficient of that particular organic chemical. And that number is available in the literature for virtually all organic contaminants. So the simplest estimation of the KD is to use the value of the fraction of organic carbon, 0.41, and KOW. And that gives you an order of magnitude estimate of the retardation factor. It's good for the first cut. There's a very good literature and good methods to improve that estimate, but in many cases that's good enough for an initial assessment of monitored natural attenuation. The important point for retardation and attenuation is that while the contaminant is attached to the solids, it's not in the water. And that is removing mass from water. So that can be an important attenuation process. So rather than the contaminant concentration versus time arriving at a well, rather than the contaminant coming along at low concentration, going up to a high concentration, and going lower at some later date when the source is removed, perhaps, retardation tends to reduce that maximum and spread the contaminant out for a longer time. So it doesn't actually remove any mass from the system. It actually distributes the mass over a longer period of time over a broader section of the aquifer. So that can be useful, but again, it's not mass removal.